Welcome to Indication Instruments.
If you operate a modern diesel, you know this sight is an absolute nightmare. The dashboard lights up like a Christmas tree, the engine loses all its power. But what if I told you a single, often overlooked component is the key to preventing all of it?
So what's really causing this? Today, we're going to pull back the curtain on a hidden flaw in modern emission systems and the unsung hero that's designed to stop it.
Stricter emissions laws all around the world, like BS6, are demanding huge reductions in those harmful nitrogen oxides, NOx, that come out of diesel engines. And to meet that challenge, engineers came up with a pretty brilliant solution.
That solution is the Selective Catalytic Reduction System, or SCR for short. It's got one job: to neutralize those nasty NOx emissions before they ever get a chance to leave the tailpipe.
So here's the quick and dirty on how it works. A fluid, called DEF, gets sprayed into the hot exhaust. The heat breaks its urea down into ammonia. Then, inside the special catalyst, that ammonia gets to work, reacting with the NOx and transforming it all into plain old, harmless nitrogen and water. Sounds great, right? It only works when everything is absolutely perfect.
And this is where our story takes a hard left turn. The entire SCR system is built on one single critical assumption: that the diesel exhaust fluid, the DEF, is the perfect, unadulterated formula. If it's not, the whole system can basically just grind to a halt.
Bad DF is absolute poison to this system. We're talking diluted fluid, contaminated fluid, or maybe it's just the wrong fluid entirely. It's going to lead to failed emissions tests, clogged up components, and, yeah, those dreaded warning lights that can throw your vehicle into a powerless limp home mode. That costs you serious time and a lot of money.
So how do you protect against this? Well, you need a guardian, and that is the DEF quality sensor. It is constantly on duty, checking the fluid to make sure it's the real deal. The best modern sensors even combine quality, level, and temperature measurement all into one smart unit.
It's an input truth sensor. It means its only job is to tell the engine's computer, the ECU, yep, the fluid we're about to use is exactly what it should be. It gives the system the confidence to do its job right.
Okay, so how does a sensor actually know if the fluid is good or not? Well, out in the real world, there are two main technologies that are used to do just that.
On one hand, you've got optical sensors. They work by measuring how light passes through the fluid. They're super fast and really sensitive. On the other hand, there are ultrasonic sensors. They measure the speed of sound through the liquid, which makes them really good at ignoring things like surface stains. But each one has an Achilles heel. Optical sensors can get blinded if the lens gets dirty, and ultrasonic sensors can be totally fooled by something as simple as air bubbles.
It's not really about which type of physics is better. What really matters is having a design that's robust enough to handle the rough and tumble of the real world, one that actually anticipates these exact problems.
A truly robust sensor is so much more than just a piece of hardware. It needs to have smart software that can tell the difference between a real problem and, say, a false alarm from fluid sloshing around. The physical design has to be smart too, built to prevent air bubbles from getting trapped in the first place. And it's got to be intelligent enough to handle huge temperature swings. That is what really protects the vehicle.
Is your vehicle's absolutely critical emission system truly protected by a robust, intelligent sensor, or is it just running blind, only one bad tank of fluid away from a total breakdown? The answer is sitting right there, in the tank. It's that unsung hero.